Welcome to The Explainer. Today, we're going to pull back the curtain on the hidden physical world that powers artificial intelligence. It's this immense global machine that we rarely ever see, but it shapes absolutely everything AI can and can't do. It really does feel like magic, doesn't it? You type a question and poof, an answer just appears. But your request doesn't just, vanish into the cloud. It sets off on this incredible journey, traveling through a vast, complex city of actual physical hardware and invisible rules just to bring that answer back to you.
All right, so let's get to it. Here's the blueprint for our journey today. We are going to build this hidden world layer by layer. We'll start with the foundation, move to the on-ramps, then make the network smart. After that, we'll talk about the human rules, and finally, the huge choices we all have to make about its future.
Okay, so every city needs a blueprint, and AI's world is no different. But this isn't just about code floating in cyberspace. We're talking about a physical reality with distinct layers, and every single one is essential for the whole system to work. We're going to explore this whole thing in 4 main layers. We'll start with the actual ground beneath our feet and stretch all the way up into space. Then we'll look at how we all connect to it, how the network itself gets smart, and finally, the human rules that try to govern the whole shebang.
So where do we even begin? Well, you got to start with the foundation. This is the massive, physical infrastructure. We're talking the concrete and steel of the digital world that everything else is built on top of.
Okay, so first up, fiber optic cables. Think of these as the global superhighways of the internet. We're talking about these impossibly thin strands of glass, buried deep under oceans and continents, carrying just colossal amounts of data with incredible reliability.
Now take a look at this map. This is so much more than just a bunch of lines. It's practically a map of global power. The placement of these cables has huge geopolitical implications. I mean, where these lines are drawn literally determines who controls the flow of data, who holds economic power, and whose connection stays up during a crisis.
But what about the places these superhighways can't reach? A remote village, a ship out at sea, or a plane cruising at 30,000 feet. Well, that's where satellite internet comes in. It uses these constellations of satellites orbiting the Earth to connect the unconnected.
And this technology is absolutely vital. It acts as a backup system for our entire digital city, preventing outages and helping connect the whole globe. But it's this constant balancing act, right? Between getting that amazing global coverage on one side and dealing with the cost and a latency, that tiny delay as data zips up to space and back on the other.
All right, we've built the global highways. Check. Now we need the local roads and all the on-ramps. So this next layer is all about how we and all of our devices actually connect to the grid.
5G is so much more than just faster downloads for your phone. Its real secret weapon is its ultra-low latency. We're talking near instantaneous response time, and that is what lets an AI do these critical, real-time actions, like coordinating a whole fleet of autonomous robots or even helping out with remote surgery.
But here's the thing. Not everyone has equal access to these on-ramps, and this creates a really stark digital divide. In cities, powerful AI can thrive. But out in rural areas, limited access can create what people are calling AI deserts, basically shaping where AI-driven economies can even emerge in the first place.
Okay, so we have the highways and we have the on-ramps. But what if our city needs to react like right now? For our next step, we've got to make it intelligent. We need to give it local reflexes, so it can think on the spot instead of having to call all the way back to a central brain for every single decision.
And that is exactly what edge computing does. It's like building these little smart substations in every single neighborhood of our digital city. It puts the computing power right where the data is actually being generated.
This is really the key difference here. A trip all the way to a distant cloud server, that can be slow and it can be vulnerable. But by thinking locally, AI becomes faster, it becomes more private, and it's way more reliable. It gains this ability to function on its own, even if the connection to the wider internet is a little shaky.
All right, the physical city is built. It's all connected and it's smart. But, a city isn't just infrastructure. It's also the rules. So now we need the laws and the city planning, the human policies that govern how this all works together.
One of the most impactful rules is the data cap. You've probably run into these on your phone plan, right? Well, for an AI, which needs to consume and process just massive amounts of data, these caps act like a toll on that information superhighway, and they fundamentally change the economics of how it operates.
I mean, these caps literally squeeze the flow of information. This directly influences what kind of AI can even be developed and used in a region. They can force developers to use smaller, less powerful models, and they create these really significant economic and capability gaps between capped and uncapped areas.
So, the crucial point here is that policy decisions about open access, you might have heard it called net neutrality, are incredibly important. These decisions will determine whether the future of AI is controlled by a few giants who can pay for the fast lanes, or if it stays open for everyone to innovate on a level playing field.
And that brings us to our final and maybe our most important section. Our city is built. Now we have to decide how we all want to live in it. And this means navigating some really difficult trade-offs. And let me tell you, there are no easy answers here.
On one hand, we want AI to be ubiquitous, to be everywhere, helping us. But how do we actually achieve that goal of universal connectivity without creating a world of constant surveillance? It's a really fundamental tension.
Do we build an open network where literally anyone can innovate, where new ideas can flourish from anywhere? Or do we allow a more controlled network, where a few powerful gatekeepers get to decide what's possible and who gets to succeed?
These are really the core tensions we have to navigate. Each choice pits a really powerful benefit against a pretty significant cost. Do we want faster responses or guaranteed accuracy? Powerful AI or affordable access? A network that never ever fails or one that's incredibly lean and efficient? These choices are going to shape the future of AI for all of us.
Ultimately, it all comes down to this one question. Understanding this unseen engine of fiber and satellites and policy, well, that's the first step. The next step is recognizing that the decisions we make about how to build and govern it today are going to define the world we all live in tomorrow.